This might be the only filter you need for your telescope. It's the OPTOLONG L-Quad Enhance filter, and if I love it, I will use it every night with my Dobsonian telescope. If I hate it, it will go to the trash. So let's find out.
Man, this is frustrating. So many nights in a row with clouds after getting gear. It's always the same. In addition to that, I have the wind coming from north and the LED lights on the street. These modern LED lights that are super strong and hard to deal with. However, I will build a wall here to get rid of straight light and the wind. But I can't deal with the light pollution that is around me unless I use a better filter. A better broadband filter because I want to capture all the objects, not only nebulae. I want to capture galaxies and more stuff with my telescope. That's the reason I want to upgrade my broadband light pollution filters so I can have a bit stronger filter to deal with this new light pollution I have around.
The L-Quad Enhance filter is a quad bandpass light pollution suppression filter for color cameras. Provides better color balance while improving resistance of light pollution. It allows you to save a lot of time during the shooting process and get better results at the same time.
But we have a problem. There's already an OPTOLONG L-Pro filter. It's a broadband filter. I made a review comparing it with other kind of broadband filters, and now I have the doubt if it's worth it to do the upgrade to this filter because the L-Pro and the L-Quad Enhance are very similar. And I want the best broadband filter I can get to fight the light pollution here. And I already started to build my wall to protect me from the wind and the light pollution. One thing is moving forward. Now we need a better filter, if possible, to protect us from all the light pollution.
This is the OPTOLONG L-Pro filter graph of the spectrum. The horizontal axis is the wavelength in nanometers. The vertical axis is transmission in percentage. The red line shows the transmission of the filter. The artificial emission lines are shown in orange and the emission lines from the sky objects are shown in green. You can see by the red lines touching the top of the graph that this L-Pro filter lets pass huge amounts of light to the telescope while cutting the harmful light pollution. But now let's see the new OPTOLONG L-Quad Enhance graphic of the spectrum. You can see that the white line is very similar to the red line in the L-Pro filter. Nonetheless, there are small differences that at a glance make me think it can have a huge impact on the color balance. Basically, the biggest differences are two. The first is visible at the left of the graph. The left side is towards the blue color. You can see that the white line from the new OPTOLONG L-Quad Enhance is larger than the red line of the L-Pro in this area of the spectrum. But it's larger towards the left, the bluish zone. That leads me to think that this new OPTOLONG L-Quad Enhance will get more blue tones than its predecessor, the L-Pro. But the second difference is visible at the middle right of the graph. Notice that one of the peaks of the L-Pro filter disappeared in the new OPTOLONG L-Quad Enhance. That means the latter cuts the light in that small portion of the spectrum, which is an area of orange color. But that's when things are starting to get interesting because I always saw too much orange tint in the live views with an astro camera paired with my telescopes while using the OPTOLONG L-Pro, especially in nebulae like the Orion Nebula, the Helix Nebula and many others that require a good color balance. Otherwise, they don't look natural. But now we need to validate this interpretation of the graphic. And to do that, we will use, of course, the power of the Dobsonian telescope. I wonder if it's also good to use with an eyepiece, for visual. We will test that. But first, there's something very important you should know about this filter. There are broadband filters and narrowband filters. With broadband filters, you can watch all the objects in the sky. They are designed to cut only the light pollution. Narrowband filters cut much more light, but they also get more contrast on the frequency they work. However, they only work for emission nebulae. This will limit your targets by a huge amount. You will exclude reflection nebulae, galaxies, etc. However, the new L-Quad Enhance broadband filter from OPTOLONG should work efficiently only until the level 7 on the Bortle scale of light pollution. From there, you should use narrowband filters like the OPTOLONG L-Ultimate, L-Enhance or L-Extreme, or move to a darker place.
Okay, I just tested the filter with the Galaxy and with the Orion Nebula to have two different objects with my 8-inch Dobsonian, and no. For visual, at least on my Bortle 5, it cuts too much light to watch the nebula and the galaxies. So I prefer without filter, but be aware that I don't like any visual filter comparing to observing objects without any filters. So I prefer to use no filter at all. Neither this one, neither visual filters, and I have 4 visual filters. I don't like any of them.
However, this filter was not designed to use in visual observations. This filter was designed to use with a camera, and that's what we are going to do right now. Okay, I'm exhausted, but finally they finished the wall. Now let's place the telescope. And now you will see different objects with this filter. Here's an excellent result with the Orion Nebula M42 with this filter and a 12-inch Dobsonian telescope. Notice that the conditions were not very good this night. Nonetheless, we got this excellent image in real time with good color balance. And now the Running Man Nebula. Also with a good color balance, we can notice in the image in real time a good detail of the dust around the nebula. But the best part was after dinner, in a live stream with you, all the Dobsonian power community and the 12-inch Dobsonian. This is the Sirius star, the brightest star in the sky, in all its glory. Flawless. And now the Bose galaxy. Remember, these are all non-processed images, all taken only with 8-second exposures, during only 5 minutes. The Bose galaxy is positioned at one of the worst positions I have in the sky because of the light pollution. Despite that, we have a great image. And now, the nearest galaxy to the Bose, the Cigar galaxy, which is also amazing. And look at the darkness of the background. One of the good features this filter has. For fun, we pointed to the moon. No weird reflections, a good color balance. It gives me a hint that this filter will work for planets as well. And of course, with the moon super bright already in the sky, we still can watch a globular star cluster. Notice on the perfect color balance of the stars in this cluster, M3. It's very nice. Okay, I spoil it, OPTOLONG. I spoil it. I have to tell the truth to my community. It's good! Conclusion. I will keep it.